everybody, welcome to 3.6 Examples A and B. So you can do problems like those in the investigation using a balance scale as long as the weight of the cup is very small. But an actual balance scale can only model equations in which all the numbers involved are positive. Still, the idea of balancing equations can apply to equations involving negative numbers. Just remember, when you add any number to its opposite, you get 0. For this reason, the opposite of a number is called the additive inverse, because if you add them together, they add to 0. Think of a negative and positive numbers as having opposite effects on a balance scale. You can remove 0 from either side of a balance scale picture without affecting the balance. These three figures all represent 0. 1 plus negative 1 equals 0. Negative 3 plus positive 3 equals 0. And positive 2x and negative 2x equals 0. Alright, so if we ever have the additive inverse, you're going to get a 0. That's kind of helpful because then stuff cancels out. Alright, so let's do this example A. It says, draw a series of balance scale pictures to solve the equation 6 equals negative 2x plus 4. Okay, so here is our picture. We already have that, right? So we have positive 1, 2, 3, 4, 5, 6, and negative 2x. So we really have 6 equals negative 2x. And actually, I don't think I need to do that because I can just do this. So there's our equation. 6 equals negative 2 plus 4x. And our action taken is, that's just the original equation. Okay, so now what are we doing to both sides? Well, it looks like I went from 6 to 8. So I added 2 here. So I added 2 here, right? So I really added 2 to both sides. Alright, and then what does that look like? Well, it's 6 plus 2 equals negative 2 plus 2 plus 4x. So really we just added the 2 here and the 2 here, right? And that 2 really matches up with the 2's that are there and there, or wherever they happen to be. Okay, good. So how do we go from the next one? Well, now I have the same on the left side, but now we've just canceled out the positive and negative 2, right? We removed the 0. So that would be 8 equals 4x, right? Because the positive 2 and the negative 2 just canceled out. Alright, so now you see these little dashed lines, which means we're breaking it up into 4 parts. So we're really breaking it up into 4 parts, which means that we are dividing by 4. Alright, so we divide everything by 4, both sides by 4, and you get 8 divided by 4 and 4x divided by 4. And then you actually do that division, you simplify, and you reduce it, and you get x equals 2 or 2 equals x. Either one works, it's kind of the same thing. Alright, so let's do the next part here. It says, in the second and third equation, so in this one, the second and third equations, remove the 0, divide both sides by 4. You saw 6 plus 2 combined to 8, and negative 2 plus 2 combined to 0. You can combine numbers because they are like terms. However, in the first equation, you could not combine the negative 2 and the 4x because they are not like terms. Like terms are terms in which the variable component is the same, and they may differ by only a coefficient. So like 4x and 8x, or negative 3x and 2x. Those are also like terms. So I could also make an example, 2x and negative 4x. Those are like terms because they have the same variable and it's different coefficients. The coefficients don't matter, it's just the variable. Alright, so like 3y and 8x are not like terms because this one's got a y and this one has an x. So they are not like terms. Alright, so let's look at example, this next part right here. Sorry. Balance scale pictures can help you see what to do to solve an equation by the balancing method. But you won't need pictures once you get the idea of doing the same thing to both sides of an equation. And pictures are less useful if the numbers of the equation aren't nice, right? If we have 1.2, then we can't really draw cups or something like that. Alright, so here's example B. Solve the equation negative 31 equals negative 50.25 plus 1.55x using each method. So we've probably already done tracing on a calculator and zooming on a calculator using your graphing calculator, so we're not going to do that in this video. But we're going to undo operations here. So I'm going to start with x. So here's part A. We're going to undo by starting with x, pick x. And then we're going to add, or multiply, not add, we're going to multiply by 1.55. And then we're going to add negative 50.25. Alright, so we have to, instead of add negative, let's add positive 50.25. And let's divide by 1.55. Alright, and what number do we have to start with? Negative 31. Alright, and then we just have to add this, get an answer, divide by 1.55, and let's do that now. So we have negative 31 plus 50.25. Enter. We got 19.25. I always like to write my numbers down just in case something happens and I forget 19.25 and I want to divide by, and I think it's 1.55. Yep, divide by 1.55. Hit enter, and we should get 12.4, let's say about 12.42. So we're going to say x is about 12.42. So there's our undoing operations. Now let's do the balance method, part B. So we have negative 31 equals negative 50.25 plus 1.55x. So what we want to do is we want to balance this out. So it means I want to undo this, subtract 50.25 or the negative 50.25 by adding 50.25 to both sides. I'm going to add 50.25 to both sides. And we end up with 1.55x, right? These should cancel out and be 0, equals, and negative 31 plus 50.25 is 19.25. All right? And then what I want to do is I want to break this up into 1.55 parts. So I want to divide this in whole thing by 1.55, divide this by 1.55. And the reason I put this blank here is because these kind of just show, oh, these are 0, and the 1.55 just kind of drops down right here. So it just kind of shows a little bit of organization to this whole thing. And then after I get my answer, I'm going to move in a little bit closer. All right? So we get an answer of about 12.42 when I do this division. And we're going to say that is about equal to x. And there would be our answer. All right, we could trace it on the calculator. We could zoom it on the graph. Let's use graphing calculators, a different video. So there is your examples. Good luck.